Alrighty, boys and girls, today we are going to be working with classifying rational numbers, explaining the difference between integers, whole numbers, and how integers and whole numbers are considered to be rational numbers and why. So let's get started with a Venn diagram. Now, this Venn diagram, the whole thing is rational numbers, but the very middle is the stuff that is just going to be your whole numbers. Your whole numbers is your stuff like 0, 3, 2, 4, 6, 8, all the things that you would include that you could count on your hands and your toes. That's all your whole numbers. They're going to be the positive ones. And again, those are still considered rational. Your next step is your integers. Your integers are the opposite of your whole numbers. So there's no such thing as opposite of 0. 0 is just 0. It stays in the whole number. But -1, -7, -14, these are all integers. And they would be in that second realm, but they cannot go in the middle even though they're still rational. Now the last one outside the rational is everything that doesn't fit inside integers and doesn't fit inside whole numbers go into rationals. And the big key is understanding that rationals can be written as the form AB, meaning you're writing it as a fraction. You have A over B. That is how you're going to be writing it if it's going to be rational. Now, they don't always have to look like that. I'm going to explain how decimals, percents are also there, but decimal and percents can also be written in form AB. So here's our examples. I already told you 0 and 1,000. Let me write down 15 thirds. Your 15 thirds, you're thinking, oh, that's form AB, that's a rational number. And it is a rational number, but it can be simplified to just 5, so it is also a whole number. So that's why it's inside rational numbers and it's inside whole numbers. Next, your integers, -7, -81. These, again, can be written in form AB if you just put -81 over 1, -1 over 1. So they are rational, but they're also integers. Here's an example of that. Let's do -14 over 2. If you do -14 over 2, that can be simplified to just -7 like we have on the other side, which makes it an integer. But it's also a rational because it can be written in form AB/fraction. So rationals, these are percents, decimals, stuff like your 56 hundredths repeating. Here's another example. 1/3 is considered to be a rational because that cannot be simplified to a whole number. And -7/8 again cannot be simplified. If you reduce it, it becomes -0.675, but it's not going to become a whole number or an integer. 1/5 would be an example of this. Now 1/5 is one of those that you can do the quick, easy, I can make that denominator 10. So 5 times 2 is 10, and if I get 10 in the bottom, 1 times 2 is 10. 2/10, again, could be written as a fraction, could be written as a decimal, but it cannot be reduced to an integer or a whole number. So here are all some of our different examples of what you are looking at. In general, your rational numbers, again, all of this stuff is rational numbers. Every integers are rational. Whole numbers are rational. But not all whole numbers are integers. Not all integers are rational. And you got to kind of think of that backwards and forwards. I expect to see this in your notes, Cornell style. Now, I did say a lot of things, so you should be able to come up with 2 or 3 sentences talking about what we did. And thank you so much for watching this video. Have this prepared for Thursday when you walk in class with your spiral out, ready to go, so we can talk about it together as our flip lesson. I hope this was informative. Thank you so much for your time. Oh, don't forget your 2 vocabulary terms also.